Welcome everybody to Dallas Programmable Robotics Group, Robot Builders Night Virtual for November 18th, 2025. Tonight we have, we'll go through our normal presenters list and see who's got an update on the robots or projects they're working on. And then we'll open the table up to discussions, whatever questions people have. Reminder, get your robots going. Saturday is Robo Columbus. The day has arrived. You've got a little over 3 days to get your robot up and running. And we look forward to seeing you there Saturday. So first up, presenters, we have Mike with an update for us.
Yeah, I guess I'm going to just segue from Scott's power thing. I decided to, there was two things with my robot. One was, I'm saying, oh, it looks like the transmission is starting to slip. And then I said, oh, maybe I'll go find a way to tighten it up and stuff. And then I looked into it and it's like, oh, this could easily become a 1 week project. So I had to skip that. But I do have a shifter in it. It has a high gear and a low gear. And I increased the PWM value, the pulse width modulated value, to the servo that does the shifting. And I think it's tighter now. It hasn't been slipping like it had been. But I think I really need to go rebuild that transmission. But that's going to be after the competition. So I figure I'll just go fix it real fast. But nope, no way. And then another one was I wanted to upgrade the power distribution on it. So there's two things I wanted to do. I wanted to do a hot swap between having an external power supply and a battery, so I could keep the computer and the sensors all running while I switch between a development mode on the stand on the desk that doesn't supply wheel or power to the wheels, and then switching to the battery, which can make it run. And so one thing I said is, oh, I'm going to put heavier cables on there. So I put 18 gauge wires supplying power from the battery and from the external charger or power supply. And I have well, on the original one, I just hooked up. I didn't have any diodes because I didn't have a hot swap capability. And I was hooking up directly to my I have a 6-volt regulator that I hooked up to my 5-volt supplies for the USB and the I, and everything was running fine. But when I switched to the battery with the 18 gauge cables, USBs seemed to come up, but the Pi didn't come up. It's like, oh no, what's going on here? And I'm presuming it was an overvoltage mode. And so I had to put a diodes in series, which is what I needed to do anyway for hot swapping, because I had a diode on the external power supply that went and coupled in with the supply from the regulator and the wheel controller. And when I got that 5-volt supply trying to make it run, I was getting really crazy results on the power. And when I disconnected it from the regulators, it got a lot better. So I was like, oh, I gotta put a diode on the regulators too. Oh, well, so my end solution was some diodes from the 6-volt. Oh, I had a 5-volt 10 amp power supply that I was expecting to use, but it couldn't hold this voltage. It would droop a lot. It'd just go up and down depending on load. And it wasn't the wires, because the wires are pretty thick. It was just a crappy power supply. And I looked at it and says, oh, it's made for Pixie LEDs. So, and they don't really care about a little bit of voltage change. And so I got a 6-volt supply, and I had to put 2 diodes in it just to reduce its voltage, because it was a really stable, and it started off at 6.5 volts. So So I got it working now. So I got a good power distribution with the hot swap capability. So I'm pretty happy with that. So that took
your transient voltage suppression.
I think that's built into my control, the controller that came with my remote control car. But you're right, I don't have that. I don't have any extra transient suppression. I have some heavy duty capacitors, but I put some capacitors in there to help. So that was like 2 or 3 days of unexpected work. So I'm falling way behind. And then I was running some tests outdoors, and it's like, God, this thing is just acting stupid. Like the planner would say, go this way, and it would actually go that way. And it would just keep going and going and going. And I would take remote control of it and spin it around, and then it would start going the right direction and go to the waypoint. Because I got my GPS working, so it can find all the coordinates within a couple meters, which is what you can get from GPS. But it would just go in the wrong direction. I was looking at the planner. The planner says go to that waypoint, and it was veering off away from the waypoint. It's like, what the hell is going on? And so scratching my head. It's like, I can't figure this out. And then I was looking at my configuration with ROS, and it had 2 planners. One was a grid-based planner, and another one was the planner I want to use. And I had them both in there. I figured it would use the right one. And I think what it's been using is the grid-based one, nav FN or something like that. And it's not rated for a non-holomic, like car-like robot. So maybe that's why I've been fighting stuff for months. And I just assumed, because I was changing the parameters in the SMAC planner, and it wasn't, well, I was just doing a lot of changes. And so I got rid of the nav FN planner, which had the label grid planner, and used the other SMAC planner, and all of a sudden it started acting good, but it was acting a little funny too. So I think I was changing all the parameters and made it weird. So I went back and just copied an example of all the parameters for that guy, and it started running relatively smoothly. So this is what I've been doing, trying to get ready. And then on top of all that, it used to run at 1 meter per second, which was my target rate, which was a nice walk. Yeah. And now it's running at 0.2 or 0.3 meters per second. And I don't know what changed, and I can't figure out how to change it back to 1 meter per second. I see all the parameters that I think would do it. I've been reading everything, and I don't understand it now. So now it's like doing a crawl, a real slow crawl. So it will take me a long time to get to those waypoints, but I think I can go to them. I do have a presentation of something weird from my IMU that I had to, tomorrow I'll see if I fixed it. So I'm going to bring up my Fox view. Where's my Fox view? Or Fox glove, I mean. And a spike out of my IMU. And this is the rotational velocity. And so it's running along, you can see at the top, and then all of a sudden there's one data point out of place and it goes back. And I was going, the filter should filter it out. Well, the extended Caron filter didn't filter that out. But I found a parameter in the Kalman filter that was really screwed me up, because I think the values were set too low, which says ignores values above this value. And so I re-enabled that and set it at a high enough level so that it can get normal ranges that I'm getting here, but doesn't get this minus 50 spike that came out of it. And I'll show you an interesting thing on the robot that I looked at once and went, it's just a noise spike. I'm sure it filtered it out, but it didn't. And if I look at my, so if I bring this up, this is the tracking on here. I'm gonna go to a slow speed on here. Let me make sure it's queued up right. Yeah, it's queued up right. Okay, yeah, so you can see that the robot is pointing in the right direction. Can you see that?
Pointing at a 45-degree angle towards the bottom left.
Well, okay, this line here is the plan. I'm not sure why it does this little curve at the end, but I think it's, but here's the plan, and then the arrow on it is right there. This is the mid-link transform, which is pointing to the robot's pointing in this direction. So it's pointing in the right direction to follow the plan, which is what you want the robot to do. And so if I go in here and I blow it up just for effect, so you can see that it's pointing in the right direction and it'll follow it. Now, if I run it, I was watching this, trying to analyze it. When that spike hit it, all of a sudden it thinks it's pointing backwards now, and it really freaks out everything, going, "Oh, what do I do now?" So it says, "Oh, I got a plan. I got to go backwards," and then it tries to move, and it's actually going forward because it's actually forward. That little spike twisted the whole thing and thought that it's now pointing the wrong direction. So I'm wondering if I was getting some spikes out of the IMU, which is causing some erratic behavior I'm seeing. So I thought this would be something amusing that you guys could appreciate. And so if I go to a simulation that doesn't have that, let me see, it's this one here.
Does that mean we need to name your robot wrong way?
I think so. It has that potential. And so I'll show you a relatively decent performance. Okay, this is my map. It's I think it's plus and minus. It's a 20 meter by 20 meter, and I've just been doing a small one like that. I haven't done 100 meters yet, so I figured 100 meters will just, since it has good GPS now, it won't just go crazy in the wrong direction. Like if I was doing a odometry.
What's this tool called? I joined late, so what's this? This is not RViz, right? This is something else.
This is Foxglove. Yeah.
But the key is
So
it's
it's
a simulator. It's not the
alternative
real
to-
thing, right?
Pardon?
It's a simulator.
alternative
It's not
to
a real thing.
So yeah, this is like you normally see in RViz, which is a grid, and on the and on Foxglove, one of the reasons I like it is you can plot out variables, and this is like the GPS graphs of it. Like if I'm bringing, yeah. So this is the area I've been working on right here, like the common area we have, and so it starts here, goes here, and then it makes it to this point. It should go this way, but it's nah. Yeah, it has issues, and then it goes to another waypoint, and then it fills up my ROS bag, so I can't see anymore before it goes back to that point. So it's really interesting because I can look at it, and then I can, if I bring this if I bring the come on. Yeah. And so here I have my battery voltage and my number of satellites. And then I plotted out my satellites in view, and I had like 20 or more satellites most of the time. So it was getting really good GPS. And this is my compass. And it's basically heading east, and the 0 on the compass here is east. And so I just have a lot of things that I can plot and to debug. So that's what I'm doing. Okay, so just for a little show and tell, I'm gonna run it at 5 times speed, just for a show and tell. So this is where my starting point is, and the GPS, puts the robot somewhere around there as it reads the GPS coordinates. It just sort of wanders around, and so basically it's started up, and it's gonna, yeah. So you can see the map went over here, which is it's doing the localization using GPS now. So it's having it's working pretty good. And that little pattern it's doing there is it's looking for the cone. It just barely missed it. And this line over here that's going in and out is ground noise. It sees the ground. And so it finally found found it. Now it's going to drive away from it. And my problem right now is it runs slow, and it doesn't turn at the proper, like the linear velocity and the angular velocity are all messed up. So I took control manually right there and head it in the right direction. Go to the next point. And you can see here that the ground sort of blocked it for a bit, and then it recovered. So then it found that cone, because the ground noise came in, and it said, oh, there's an obstacle there. And then it went away when it moved a little bit. And here it got close to the cone. It says, there's a cone somewhere here. And then it's doing a little dance to try to find the cone. And then it goes and finds the cone. But this is where my ROS bag terminated before it touched the cone and went back to the map. So that's my presentation. That's my show and tell. I'm going to stop sharing unless someone has another question for this part.
That's excellent, Mike.
Yeah. Oh, you can see the robot's pointing the opposite direction, so the compass is working pretty good. But sometimes that's a different story. Sometimes it doesn't. So I got all the workings of a robot, but the software sucks. I haven't figured out how to get ROS to do what I want it to do. But I think now that I have the right planner, at least I'm on the right track now, and I think I can go forward. But I don't think I can beat Scott this weekend. But I can do better than an honorable mention. I'll probably at least touch the cone once.
Well, there's always the mug.
Label that
You only need 1 point for a mug, so.
Yeah. And if yours blows up, maybe I'll be the winner.
Don't be mean.
Yeah, there've been a lot of reports of being able to see the aurora borealis in like Leonard, Texas, which is a town not too far away from here. So I was wondering, maybe Scott seems to be having issues, and Mike Williamson, it's like, ooh, I don't know, could it be the aurora borealis that's screwing things up here?
Yeah, but that's only at night.
Well, damage is done,
Well,
I'm good with it, Ray. I think that's a great explanation. Some sort of solar flares or some crap, right?
Mm-hmm. Yeah. Ionized radiation in the atmosphere.
Yeah. Or just sheer bad luck, one of the two.
Yeah, but that IMU noise just drove me nuts when I was doing my simulation. When I was checking my ROS bag and I saw the robot flip, I went, "Oh, this is bad." So
That's the same thing I thought when I saw the blue flames. This is bad.
yeah.
Mike, how do you get data out of the, let's see, what would it be? The VL53, I think L8CX? You've got like 3 of them on there, right?
I have one of them. I have one BNO 85.
Well, no, the time of flight sensors, the 8x8
Oh,
grid.
the time of flight. I2C.
Okay, so that's the interface. Did you just go to GitHub to get something, or use what Palulu recommended, or?
What was my library? I'll look that up and get back with you. But I used a Arduino library.
Oh, okay.
And what I do is I have a regulator, because they draw too much power for the output of my microcontrollers, 3.3 volts. So I have a 3.3 volt regulator on the board with an enable pin. And so when I start up, I cycle the power on it, and then everything goes back to their default I2C address. And each of them has a pin that enables the I2C. So you enable one, set it to a new address, then enable another, set that one to a new address, and enable the other one, set it to a new address. But the trick is to be able to cycle power on them to get them back to the defaults, because there isn't a reset pin on it.
Yeah. Okay. Yeah, I'd be kind of curious. It's supposed to, I think they say you can do, like, I thought up to 60 hertz frame rate on the thing, and mine is nowhere near that. It's slow. So
I think I do 30 or something, but I think I can do 30, but I think I just do 10 just to keep things simple. And I run the I2C at megabit per second. And
oh, you do? Wow.
Megahertz. And but to get it to work with long wires, I had to put a I2C buffer on it, repeater, because it just wasn't working good when I just had a 2-foot wire on it going to the sensor, which is like the front of my robot, and it just wasn't working well. So I used a Adafruit. I can't remember what it was, but it basically is a repeater, a TI repeater on it.
Oh, okay. Yeah.
Buffer chip, and it works really good. So it took me a while, a couple tries to get it. It's not a too bad of a schematic, and the software is not too bad either. It works good. Yeah.
So do you look at the status values, or
you got to look at the status values? Yeah.
So you
got to filter out the ones that don't have good status. And yeah, that was important. I was not using it for a while, and it was just getting noise coming back.
Okay.
I mean, lots of good data, but some noise, which isn't good. I started just filtering it with the status before I sent it up to the upper level computer, and so the upper level computer doesn't get the status; it just gets good values. So
yeah,
what value do you push to it though, Mike? When when the status tells you this reading's not reliable, right? What value do you actually push?
I think I push not a number, NaN.
So basically an invalid number.
Right. And then everything else just ignores it. So
One thing I found, one technique I use that seems fairly effective, because you see that in a lot of different sensors. You'll get, your erroneous out of range sensor, or you'll get a hit on a piece of grass or something. I'll usually filter it the first couple of times. In other words, it's almost like a debounce, right? So I was like, is that reading really what you want me to process? So I'll actually process it 2 or 3 times before I say, oh, that's an obstacle, or that's, was just an erroneous value I need to throw out. When I get continuous errors like what you're talking about, I usually send the last value for some period of time. So it'll time out eventually and go to 0, right? In other words, there's something right in front of the sensor, so the robot will stop basically because you don't really know what the range is. So those are some techniques I usually use that help, especially with those one-off situations. Don't trigger just on the first one. Let it debounce it a little bit is typically what I try to do.
Yeah, I was hoping that the extended common filter in ROS would do that, but it just took that huge number and swallowed it and twisted my robot around. It was like,
well, certain values aren't going to change a lot, right? So if you get a step value of greater than whatever number, something's not right there. Especially like on a yaw value on your IMU, right? You're not going to just spin around 180 degrees in half a second or a quarter of a second, right?
Right.
So that's just not a realistic movement.
Yeah. I do use a median filter on a lot of my sensors, and what a median filter does is it takes let's do something simple like 3 values, and looks at the 3 values and then sorts them and takes the middle value. That's why it's called median, and that's a really good noise reducer.
Yeah, there's another technique called normalizing the data, right? So no matter what the sample size is, you normalize it. So you say, well, what's the lowest sample? What's the highest sample? I'm going to get rid of those.
Right.
And then I'm going to average all the other samples together, and that's going to be my median or my normalized value for that sample set.
Yeah. And the beauty of that filter is it doesn't have a lot of memory and history like an IIR filter or something. And so it doesn't really add any weird artifacts. It just has a tiny bit of delay.
Right. I do that a lot with when I take analog readings, because whenever you're reading an analog pen, they're always just bouncing all around. So if you take a single sample and say, well, that's, I'm going to look for a trend of, of these single samples, you'll chase it around all the time. I mean, I see Ray shaking his head. He's been there. So usually I normalize it, which is basically an average with the high and low thrown out. And there's some lag there because you're collecting multiple samples and then, analyze or, computing it. But, well, in the case with analog samples, you can usually sample an analog pen much faster than you really need the reading to be updated. Right. So you can lose a little bit of time there and have a more stable value.
Oh, another thing I did on my GPS is my start point. I don't type in a number because I'm using a normal GPS, and so it can be off by a lot. So what I do is I take the GPS coordinates and just do a meter I just map it out in meters to the different waypoints. And then for the GPS localization, right when I start my navigation, I read the GPS signal at that time, and that's my start GPS that I use for localization. And so that helped me from having a big drift error, because before it was like way off sometimes. So now it starts there, and then the software inside the ROS can handle the drift on the GPS and correct for it, localize, take that drift out. But if it starts off with a bad GPS signal relative to what the GPS thinks it is at the time, then it's just a big offset of, many meters. So I decided, instead of typing it in, like go into that and try to measure it with a phone or something, I just don't do that, and I let it measure it at the start point, and it worked out much better. But I did have to give it a GPS coordinate at initialization time, when the software initializes, to set it to the right GPS zone. I can't remember, what is it called? Oh, so basically GPSs have little zones that it uses for converting from GPS to latitude, longitude into meters. What is the name of that? I can't remember. It escapes me now. But you have to have you have to be in the right area of the world. And so you can't just have a bogus number like 0. And so I got to make sure that I got that, so I'm in the right basic rough area. Then when I start navigation, I give it the actual GPS coordinate, and it switches over to that. So I've been learning a lot about how to use GPS. So in the constructs of the ROS software.
Now, a quick side question. So in terms of GPS modules, are there any like really cheap, like budget ones that you would recommend for competition similar to Roborama?
Tom Crawford looked at several. Do you have a recommendation for a cheap GPS that works good, that's not a horrible clone of something that actually does work?
Yeah, off the top of my head, I don't. I would have to go and look through my past presentations and see what I was recommending. I tried some off-brand Chinese-based stuff out of AliExpress. Was eventually able to get them to work, but with a great deal of trouble because they're quite non-standard. But they eventually worked. The God, I can't remember the names of the very popular US-based brand that I have been using at the low end of the scale with good results. Somebody else, half you guys probably know what I'm talking about. Is it
U-Block?
U-Blocks, yes, thank you. The U-Blocks units. And I use the low-end versions, the M8s, I think.
Yeah, I'm using M8, I think. Yeah.
And I find the M8s, they're not the best thing they make, but they're quite inexpensive, readily available. If you're going to buy M8 modules out of AliExpress, be very, very cautious about the off-brand clones and the outright fakes. So you need to watch for those. I got some of those.
They just not work well, or they just have a different interface, like different libraries?
They're labeled as U-Blocks M8, and internally they have a not very good Chinese branded version that doesn't even work the same way. And you can tell them. There's a lot of discussion online about how to identify them. And that was one of the presentations I did back a year ago, where I showed some of the examples I ran across, plus a whole bunch more that I identified and did not buy. I was amazed that these guys basically print the label that goes on the little metal module, and they do a horrible job of printing the little label that goes on the module, and that's how you tell that it's a counterfeit. You just have to look at the label really, really closely and then compare it with a known good U-Blocks M8 label. And you immediately can see the printing differences.
So the data that comes out of it is just crappy, or is it just the wrong format, or it's just not the right scale or whatever.
If
Sure.
the data doesn't come out in the right format, and when you attempt to interact with it, because these things are programmable and configurable in various ways, when you try to configure it, you can't. It doesn't respond.
So an M8
Yeah.
library would not, an Arduino M8 library would not work.
No, you have to identify what the internal Chinese chip is,
Right.
and then look for a library that knows how to talk to that chip. They're out there. I did find several of them. I did make them work, but my God, it's a pain in the ass. You saved $1 on and ended up buying a counterfeit part.
Well,
I
my
thought
advice too
data
is that that's not an area you want to skimp on, because that has a large part to do with the performance of your overall robot. And if there's any place you want to spend a little extra money, it's in the accuracy of your positioning system. Like I'm using, I think it's the F9, which is the series above the 8s. And that'll give you RTK capabilities if you want to grow into that. I think the M8 doesn't do RTK, if I'm not mistaken. I don't know, Tom, you can correct
No,
me.
it does not. It does not.
So that
There
would
are
be my
some M8s
advice
that
anyway.
do.
But it's a lot less
Yeah,
expensive.
there is.
Yeah.
SparkFun has a unit that'll do. It's an M8, and it'll do RTK.
Oh. Wonder what M8 means. Okay.
I just want to jump in.
M8 is just a family of silicon. They have so many different products within each family, but they've got the 8s, the 9s. They have the 10s now.
Right.
I want to jump in here and say I agree with Scott totally. If you don't want to skimp on your GPS. I mean, you can even get M6s that'll work fine, but what you get for the higher numbers, the M7, M8s, and M9s, is you get a lot more sensitivity. They're actually GNSSs instead of GPSs. They're like I say, you can buy them with RTK capability. Those are a little more pricey if your budget, but it's SparkFun has a reputation of being legit when it comes to GPSs. So this is a case where you probably want to go to SparkFun and take a look around their selections. They have everything from, pretty cheap to very, very expensive. So you just take a look. I actually, and another possibility is if you want to use the RTK is to go to DF Robot, and they have an RTK set up. I've bought one. I've tested it out. I like it. I don't think I'll be using it Saturday, but it's that one's $160, but you essentially get a turnkey solution for RTK, and you don't have to use it as RTK. I mean, it will work as a GPS if it doesn't get an RTK signal. So it's something you can grow into. Anyway, those are things to think of. But and I've gone the same route Tom has. I've got a whole box load of inexpensive GPSs that I've picked up. Usually the ones that I've been picking up are really super small, for like drones. And I'm not sure I can give you an exact reason why the ones that are from China have problems, but I can tell you kind of what it is. They got a license from UBlot to make older generation GPSs, but they can also, a lot of the configurability that you get with a real legit UBlot GPS has they have the ability to use to configure them. And there's a chip, and I want to say it's a static RAM or an SRAM chip, and the Chinese ones that's built into the GPS, and the ones from China don't have that. So they're non-configurable, they're non-upgradable. You go out to U-Blot Center or U-Center, and you'll just find you can't do it. You might be able to get it to read, but that's about it. So, you know, you can get those probably for 20, like here's one for this one here. You know, they got to be selling the GPS for $10. What is it? Does it say? This is they're saying they're selling. Oh, okay. The GPS is $30. You know, Adafruit, I would believe, but you want to read what you want. I kind of like the U-Blot ones myself.
Yeah.
And
there's a unit there that it doesn't do RTK, but it's $30. It's got stemma connectors on it. It does, you know, I think supports 4 different
addresses.
You know, systems, US, Russia.
Crew GNSS.
Yeah, GNSS, basically.
Yeah.
Constellations.
Yeah. GPS, GLONASS, Galileo, and QZSS. I guess that's the Israeli one.
No.
Oh,
I will say, you know, with one of the
Japan.
Oh, that's Japan.
Yeah.
Okay.
I think.
Yeah. And I don't know if they cover too much of us. They're not as extensive, I don't think. But anyway. But you did ask a very specific question, which everybody has skirted over or didn't hear you correctly. You asked in such contest as Robo-Rama. Robo-Rama is inside. You should not need a GPS to do anything in that. So, I mean, that's none of the contests we run require a GPS. So they're really only required when you move outdoors.
I have my presentation on the counterfeit GPSs here.
Well, yeah, Tom.
And incidentally, they were Neo 6Ms, U-Block Neo 6Ms.
Yeah.
You want
I
to see
posted a link, Tom, to one I think you had reviewed as well.
Yeah.
the link?
Can you put the link in chat?
I did.
Okay, cool.
I think Tom did a review on that one. When I go to look, it's labeled as an M10 from AliExpress.
Okay, I never bought any M10s, I don't think. I know I'm not using 6Ms anymore because I found ones that were more accurate, which aren't in front of me right now. So to be honest, probably not worth buying 6Ms. So probably not worth getting excited about the difference in the counterfeit ones. Go buy them.
I thought somebody had done a presentation on that one. That's where I got the link.
Yeah. So Kyle, what were you going to use the GPS for again?
I just out of curiosity because, or like at least for the Robo Columbus, I've heard some people do use GPS for navigation. It's too late for me to like order off of AliExpress, but I just out of curiosity if there was a future upcoming event that either use GPS or anything like that for navigation.
Yeah, so GPS is used for localization to help navigation, and in Robo-Rama, like you said, it's indoors, so GPS is completely useless. But a really inexpensive LiDAR system, rotating LiDAR, works really good for localization.
Yep.
And now, sorry. So for the Robo Columbus, the one that's outdoors, how important is localization? Like right now, for if I get my thing working in time, it's not going to be using any localization, maybe LiDAR for navigation, but no GPS for localization. Can I pull it off? Like if I just use a camera and LiDAR, or how hard is it without a GPS?
Okay, Kyle, what I would suggest is shooting, like Scott said, you only need 1 point to get a mug. Okay, and I'll be quite honest, if I get a mug, I'm happy. Okay, so I mean, that's where and so it is possible. I'm not saying this is the right way to do it, but you can aim your robot at the first cone, and you can have your IMU, correct for all errors, so that it's always trying to maintain the same heading, and you can figure out how far the cone is, and if you can get within 10, I think it's 10 feet. 10 feet of the cone, what we do is we actually spray paint a 10-foot circle around the cone. And if you get in that, you get a point. Even if you don't stop, all you have to do is cut the circle. If you go through the circle and end up in the lake, doesn't matter. You get your point, you get your mug. So, that should, at this late stage in the game, that's probably where I would aim it at.
Yeah, Kyle, I got a mug doing exactly that, using a gyro and a wheel encoder for distance.
Yeah.
And if you go into the lake, we have 25-pound bags of rice that you can set your whole robot in. No.
A kill switch is really important. Yeah. to be able to stop it.
And I did it once with just an IMU. And because you can see the first cone from the home base.
Right.
So you just aim it in the right direction and let it go. And as long as you can drive straight and then kind of zero in on the cone, you're good for a mug.
Yeah. But you got to realize that it's not a really flat surface like a basketball.
Like it's not like a sidewalk.
Right.
Nothing like a sidewalk.
Yeah, hills and bells and cracks and crannies. Yeah.
It's got clumps of grass and rocks and erosion.
So if I have an IMU, will I need an encoder, or could I just from the IMU and the LiDAR and the camera navigate without an encoder?
Well, encoders would make it easier, because then you would know approximately how far you went. Okay, without encoders, you kind of have to fall back. There's two ways you can do it. You can go and say, if you have a GPS, you could go to you could go to the set point, you know what I mean? Or you could also do it, if you know the speed of your robot and and the distance, you could figure it in time, but that's really getting pretty iffy if you're doing that, because you're going to have a lot of wheel slip. You're going to be bouncing around. If you have an IMU, you only need a 6-degree one. Okay. Because all you're trying to do is maintain a zero. Otherwise you point it. So you want zero. You want your reference is 0. You don't want to go anywhere from the angle, whatever angle you're aimed at, that's where you want to go. So you want it to correct for that. So you just put a PID loop around it. That's the way I would do it. And you just shoot towards it.
And as long as you
run over the cone, does it really matter how long you go if you're pointed in the right way?
Yeah, right. Because all you have to do is cut through the circle. You can even hit the cone and knock it over. It wouldn't matter.
Still get your point.
You still get your point.
And then use your kill switch to stop it before it goes into the lake. Yeah.
So yeah, there is a low bar. That's the whole idea of Robo Columbus. Robo Columbus goes from everywhere to very simple 1-point strategies all the way up to 11-point strategies. And we have never had anybody go over 9. So there's a lot of room for growth.
Kyle, I've found that the LiDAR doesn't do anything for localization because you don't know the map or anything, but it's a pretty good obstacle avoidance sensor to keep from running into stuff.
Okay, speaking of the map, so is it expected that the robot, like, is it going to be pre-programmed that it knows like the general map? Like, is there a map layout somewhere online, or is it going to be completely random and the robot's expected to figure it out and guess?
Well, we're given 3 GPS coordinates of where the cones are, and we're
nothing about the terrain or the landscaping or anything.
Yeah. Right.
I think the real question is, does he get it ahead of time? So what's going to happen is they're going to go out to the place, go lay out the cones in some random location at the place, and then when you show up and get ready, then that's when you'll get the coordinates, and that's when you'll get all the stuff. There's no pre-planning the coordinates on here other than just day up.
Yeah. But some people put intermediate waypoints in, so they got to go and walk the place and get alternate GPS coordinates for alternate waypoints. But,
yeah, that's a good way. If you don't have really strong obstacle avoidance, that's how you get around it.
Mm-hmm. Yeah. But without GPS, it's hard to do. So,
yeah.
But it seems like, Kyle, your best shot is to try to get close to the first cone. And it'd be great if you could use your camera to go and approach it and touch it, and then you get 2 points, I believe. But,
yeah, and if you stop when you touch it, 3 points.
Mm-hmm. Oh, okay.
Yeah.
But if you knock it over and run over the cone,
probably you get 1 point.
Oh, okay.
You get, yeah. But like I say, we want people to try and run it, and that's why they have, all of these levels. So,
all right, I think we got off subject of our list.
Yeah, Mike, were you done with your topic on your robot?
Yeah, we're just got into the chat session.
Yeah, I just wanted to make sure you were done.
Okay.
Any more questions for Mike? Okay, next up we have John. John wanted to show a few things he found on the net.
Okay, so let me share screen. That's one here. And that'll work. Here we go, John.
Mike,
God, I have one of those antiques.
Going camping, yeah.
Mike, by the way, I gave you a black star for significant progress on your robot.
At least I'm going forward. A couple of weeks ago, I was going backwards. So, yeah.
Okay, so yeah, unfortunately, you're going to get a little advertisement and throw him, but seemingly there's engineers that they have a wearable system, and seemingly, speaking of outdoor Columbus, that seemingly when you move around and stuff, these sensors get confused. So they seem to have overcome the challenge of wearable technology. So there was a noise tolerant human interference paper out there. So you might want to, for that type of information, read this article. So that was, I thought, sort of interesting for those people that, are trying to filter out. So there's that article out there, and basically the title is that. Well, machines, robots while on movement. So that's the first one. And then the other one I saw was this one on Instructables. So for the person that's doing the AI chatbot thing, you might want to look at this one because it looks cute, amongst other things. So there's that.
That's something for Kareem. Kareem could use that face on his robot.
So that was the other article I ran across I thought might have interest to people.
The face of Barney.
So yeah,
I think Mark has built those eyes also. Is that correct, Mark? I thought I saw him.
so yeah, there's the article. You can see it. Pretty good. So
yeah.
So that was the other thing I ran across I thought might be of interest.
I thought Harold did a set too, didn't you, Harold?
Mine were OLEDs.
Oh, okay.
Was it John Gauthier?
Oh, yeah. Yeah, that's who it was. Yeah. I thought Harold maybe did it too, but I guess not.
John used to make all the Halloween stuff, and he made I think it was a skull with a set of eyes in it.
So yeah, those were the two articles I thought, somebody might be interested in to look at.
That's cool.
And as I said, they have a pretty good article on this one about how to wire it up and all that. So the control
Are there
room.
cameras in the eyes so it can see stuff and measure distance?
I don't. Well, let's go back to the list of items. There we are. Driver boards, joints. No, it doesn't show that. They could be added on, I would imagine, without too much work.
Yes, you got binocular vision, so you can measure the distance to what you're seeing, like a human eye does. Or two eyes. Takes two eyes to do that.
And they do have a speaker, a microphone on it, so.
So is the AI running on the Pi, or does it need to be hooked up to the cloud?
I would think the cloud, but let's see, what does it say? Because
a Pi 5 is really a lot of power to run just some gimmicks like that, unless
they have a Python script before adding the AI functionality. Okay, a script to test the movement. Okay, and then from there it says, okay, there's where it says how it goes about approaching that. So 3 stages.
Okay. Okay, open AI API. So it's API to the cloud. Yeah. Okay.
Yeah, if you're interested in adding the API to face, you can. Here's an article that basically, and then it has that Neil Pitzel mouth thing. See, really.
Yeah. Well, a 5-volt, 10-amp power supply that's only good for running like pixels. Don't run your electronics on it. Yeah.
So those were the 2 articles I ran across this week. I thought might be of interest to somebody.
Well, thanks, John. Okay, next up, Matthew, are you ready for your presentation?
Yes, I am. Okay, so y'all probably remember that I was working on the micro mouse last time. I had just gotten the PCB and the motors. However, as of Saturday, I got the thing partially assembled here. I'm not sure if you can see it, but I do have the components on the board now. But there were a couple of hiccups as I started to test. So The first being that these parts are very, very small, right? So they were actually quite challenging to solder. I did a half decent job, but about 3 of them weren't soldered down correctly. So I was not able to test certain functionality. So 2 of those were the sensor amplifiers. Those allowed the microcontroller to control the infrared or to control the infrared LEDs that were used for the wall sensors. So those were actually hooked up in correctly. The other part that was problematic was actually the IMU. I used a gyroscope to measure the speed of the turns. That one, I was not able to connect that to the microcontroller. So I think there's probably a short or some kind of bad connection, but I can't actually see it because it's the package is an LGA. So the pads are under the plastic, so I can't even see if they're shorter or not.
Yeah.
So I was able to test about half the functionality. I still have to test the motor driver, but I'm hoping to have that done in the next couple of days. That being said, I did start a new version of the circuit board because of the MOSFET issue that I just talked about. This one, I'm taking a slightly different approach. I'm not going to solder this one myself. I'm going to try just having JLC to do the assembly. The reasoning for that is the competition is in March, and I need to have something that's working pretty soon so I can start validating all of the maze or the maze solving algorithms that I've worked on. So I'm going to have them assemble it. I was able to remove a couple of components from this board. I learned that I actually don't need the external crystal oscillator. I don't need a lot of the pull up and pull downs because the microcontroller has those built in. So all in all, I was actually able to remove about 8 components from the board. So I'm pretty happy about that. The second major part that I did is you can see that there's more components on the back of the robot now. The reason those weren't there originally was that my hot plate is very small. It's only about 3 inches by 3 inches, and that's what I used to assemble it. So I had to fit all of the components on that hot plate. But this time around, since the PCB house is going to do the manufacturing, I spaced everything out into a more spacious arrangement. So I guess we'll see how this goes. But I think I fixed all of the problems. Hopefully, 3rd time's a charm here.
That's some progress. You're figuring out where your problems are and working your way around them.
Yeah, it's yes. On the first mistake with the MOSFET, it is actually kind of embarrassing. I'm not sure how familiar y'all are with the way that MOSFETs work, but I accidentally created a high side switch using an in-channel MOSFET. So when I tried to turn on the MOSFET, I lost control because the way the voltages worked. So I had to redo the schematic. So this circuit board wouldn't have worked anyway. I wouldn't have been able to control the LEDs with the dexterity that I needed to. But that's fixed now. As for the gyroscope, I'm gonna take my hot air gun, see if I can resolder the IMU, and hopefully I can get it tested. But yeah.
Does the battery go in that rectangle in the center?
No. So yeah, the rectangle in the center is just a comment that I made. This is where where the motors are going to go.
Okay.
So the battery, I don't have a great place for it. It's probably going to go in the section on the front by all the electronics.
Mhm.
Um,
3 double
I think-
A's or
oh no, it's going to be a really small lipo from Adafruit.
oh, okay,
Yeah.
okay.
Yeah, I haven't chosen the battery yet because I didn't bother to calculate how much power this robot I was going to use. So I'm going to just turn it on and do some tests with the motors and then size the battery appropriately.
Mhm.
So I think it's going to end up, yeah, I think it's going to end up all right. I just need to sort through a few little problems and then we'll get there.
That's good. Gary suggests instead of unsoldering dry MU is to invest in an eBay X-ray machine.
Can you buy those?
Yeah, buy anything on eBay.
Yeah. Actually, I think if you have the PCB assembled by JLC, they'll actually do X-ray tests if you pay for it. It's not that expensive. It's all done in China, so they can do it pretty cheap. Most of my components are QFPs, but I have a couple of those LGAs. The MOSFETs and the IMU are the ones that come to mind. I was thinking about changing that just for for ease of construction, but I don't think you can even buy this gyro in different packages. Most of these fancy new ICs are coming in smaller and smaller packages.
That's just what us old guys need is stuff coming into smaller packages.
Yeah, I thought I had steady hands until I was trying to assemble this thing. It was a challenge, even with my manual pick and place contraption. I think I mentioned a couple weeks ago, but I built this thing out of aluminum extrusions that has this tiny little needle tip. I don't think the camera can even see it.
Barely coming through.
Yeah,
But it's very, very fine. It's like a blunt tipped hypodermic needle. So I attach a vacuum pump to this thing, and then I can pick up the parts and then turn off the vacuum pump, and then it drops onto the pads, and it works pretty well. But even with that, it's kind of a challenge to get it lined up.
Is that better than tweezers?
Oh yeah, tweezers are fine if you're doing larger components. Like for example, on this board, I have of the gold a rectangle about right there. That's the crystal. I was able to place that one by hand, but really on the rest of the parts are QFNs, so the leads are under the device. And if you smear the solder paste around, then you often have bridging, and that causes some problems.
How high above the board is the device when you go to place it?
Oh, so okay. Here's the cool part. I think I can grab it. Here, 1 second. So the first time that I tried to show this, I didn't really have a good setup, but I've kind of upgraded on my webcam. So let me get the other needle so it's a bit easier to see. Actually, never mind. I don't know where it is. I think I moved it somewhere else. But so here's the head to this thing. I screw the needle into this part right here. And then there's a tube right here where the vacuum will connect to. I have this this little handheld, or this, what do you call it? A manual linear range. So as I turn it, you might be able to see the entire mechanism going up and down. So I have very fine So I have very fine resolution on this thing. So it allows me to get really close to the pad and get it perfectly lined up, and then I can drop it on. And it works pretty well. I'm pleasantly surprised with it.
Yeah. So you move the board around under it manually until it lines up with the needle, and
that's
then you
one way.
drop it down.
So that is one way to do it. I have a silicone ESD mat, and this whole thing actually has the perfect amount of friction where I can just slowly move it around. Like
you move that.
So it just kind of, I can move the entire mechanism very smoothly, and it's actually easier than moving the circuit board. So that's how I did this part. So even with that, I think I'm just going to have the PCB house do it. It's going to be faster. It's probably going to be more correct. And then I'll finally have the opportunity to power up this thing and start testing without having to debug solder joints and all that fun stuff.
It's an interesting setup you have there. Let me add a few comments. This is the device that I actually use for quite a bit of assembly. It has a needle on it right in the front. They come in different sizes. This one's for very small stuff. But like you were saying, this one has a button on it. So when you get the part over the board, so you
you're out of field. You're out of field.
Am I?
Yeah, I see it, Scott. I've actually,
we can see it.
I've used those extensively at work, but I haven't really had a good experience. Maybe it was just the particular one I had. But
this one here, I use quite a bit. And like for larger parts, I have different tips. You have, let's see if I can get it in here. So the tip comes off. And you have, where's my tips at? So you have like tips like this, which have like a rubber boot on them for larger parts. But one thing I found is to make this work, you really have to have a stencil, and you need to have a stencil printer so you can place your solder paste accurately. Because like you were saying, you get a lot of bridging. If you just, I've actually done where you just take solder paste and you kind of smear it around, and then you take a hot gun and you let it kind of ball up and draw up, which kind of works, for larger pitched parts. But like the parts you're working with, 603s and below, and the QFNs like you're talking about, you have to have
I do have a stencil, and I use a stencil for this. And the solder paste application, and the solder paste application actually went pretty well.
So, but and I've also found that you don't really have to place the part super accurately, as long as it's enough on pad that the surface tension, when you liquefy the paste, it'll actually pull the part into line. For instance, like this is a board that I built through that method, and you can see there's a bunch of resistors here, right? I'm trying to, there we go.
Yeah, I can see it, yeah.
When I placed these, they were just kind of haphazardly placed, but it looks like they're almost perfectly aligned. And that's just simply from the surface tension of the solder paste when it's liquefied. And with smaller parts, you get away with that. But these bigger parts here, you really have to be careful about getting them on pad. But like I said, I found that you really don't have to be too accurate with the discrete components, especially ones with just 2 pads on them.
Those are pretty easy.
Pretty well. Just kind of some of my experiences that I've had putting boards together.
Yeah, I wonder if my solder paste is getting old, and I've heard that can negatively influence the quality of of solder application you get.
If you look at it under magnification, and you can see like little balls or little beads in it, then yeah, it's starting to dry out because there's a medium that holds those balls together, and normally it'll paste it over. So all you really see is a paste consistency. So that's one thing I usually kind of look at if it gets real grainy, kind of thing. And you know,
some
like
volatile solvent
from
leaves
Mauser or
or
DigiKey, you can get, I don't know, whatever it is, half a gram for like $15.
Yeah, that's what I did.
And it's so and you know, you said you had a hot plate, which is a perfectly good way to you know, liquefy it. How are you controlling your hot plate?
So I bought this thing from Adafruit. I probably should have bought a bigger one, but it has a temperature sensor in it, and it controls the temperature profile.
Okay.
But if I take my board and put it on top,
Yeah.
you'll see that on that there is some overlap. So the board is acting as a big heat sink. And I'm not sure that this thing has enough power to counteract that. So it takes quite a long time to heat up. I'm not convinced it's getting up to temperature. So if I were to use this hot plate again on a board this size, I'd probably use the hot air gun at the same time. You know, use the hot plate to warm up the PCB and then use the hot air gun to finish the job.
Yeah. Yeah, because with a board that size, is it 4-layer as well?
Correct.
So yeah, there's a lot of thermal load on there. And yeah, I would share your suspicion that your little hot plate may not have enough juice to really get it good and hot to flow your paste good.
Yeah. The other thing that I think I did wrong. So the first board that I did a few months ago, I used a lot of paste on the pads. So let me switch back to my PCB thing here, and I'll show you what I mean. If I look at the paste layer, you can see that there's a decent amount of paste. But when I ordered this board, these gray rectangles were even smaller. So there probably wasn't enough paste on the pad to do the surface tension thing on a few of these.
Well, that's affected by the thickness of the stencil, and typically whoever's burning the stencil knows what the ratio should be for that pad. So yeah, your hold off there. I've had board shops do that to me too, where they'll change the hold off because of their process, or like if you're ordering from JLC and you're ordering a stencil there, there's actually a checkbox to let them decide the thickness, right? Based on the pitch, the different parts and the different pitches and the density of the board.
So based on your experience, Scott, if I'm going to have these manufactured by JLC, should I let them handle the stencil thickness? For these boards, I use Osh Park. So I just sent them the stencil file, and they sent me exactly what I asked for.
Right.
If JLC is doing the manufacturing, should I just let them do it?
I mean, that's a good question. I've never had JLC assemble boards for me, so I don't know. My speculation would be that you wouldn't define it to them, right? Based on their machine, how they're going to do the stencil and how they're going to do the paste printing. That's up to them, and it's per process. Like when I work with commercial, contract manufacturers building PCBs, they actually will spec that don't set your hold off to 0, and then we'll adjust it based on our process and our machines, because they know how that works much better than I do.
Yeah.
And it's their responsibility anyway to to come out with a quality product.
Mhm.
And I'm sure JLC will do the same thing.
Yeah. And I've heard that even in commercial settings, sometimes it takes some trial and error to get the paste thickness right, the aperture size, even the speed that they apply it. It's not always an exact science. It takes some trial and error.
Yeah, it does. And the surface finish makes a difference too, right? If you get a HAL finish, you've already got solder on the board, basically.
Mm-hmm.
If you have like an ENIG finish, now you don't have any paste actually on the PCB material.
Yeah.
So that's also something that I would presume that JLC is going to want you to spec what surface finish you want them to start with.
Yeah, they have the HAL and the ENIG. Mine are ENIG right now.
Yeah, that's what I usually go with because it's flatter. I've had a lot of instances, especially larger parts like the 100 pin micros can sometimes get uneven because the hot air doesn't always blow it off evenly. I've actually rejected boards because they weren't cleaned properly and they had too much of a ridge on them. So I always go ENG. I think there's another ENIG or EING is another one that they use. It's a different mixture of nickel, I think they put on there.
Yeah.
That's usually my surface of choice. Yeah, because I don't want to pay for the gold. I don't need it, and I don't want to pay for it. So
yeah. Yeah, so I'm gonna try to get this board ordered in the next couple of days. I want to see if I can recover my gyro and do some tests with the motors. But after that's done, I'm gonna get these boards ordered.
So Matthew, are you just having the surface mount parts flowed by JLC, and you're going to do the through holes?
Yeah, I've got some tweaking to do on the through holes. I have these photodiodes and IR emitters. I need to angle them correctly and probably 3D print some kind of mount so they don't get knocked out of alignment if the thing crashes onto a wall. So I'm going to handle that, but those are the only through holes. The only, it's just those 8 parts that are going to be through hole. The rest are surface mount, which is convenient for me.
All this talk of fine motor control. I used to have an English teacher named Miss Gorman, and she was an alcoholic and had the shakes. And she there's a play, I can't even remember the name of the play now, but and a book that we were assigned to read, and this kind of emphasized certain passages in the book and how they should be interpreted and all this stuff. And she would always turn the volume up on the record player and then try to get the arm and the needle on the thing, and she'd always bounce it all off the record. And it's every time it's volume up. Okay, let's see if we can get this on here. So I guess moral of the story is if you've had too much coffee, maybe not, don't assemble your printed circuit board that day. Maybe, wait till the next day or something.
Yeah, I'm just hoping this doesn't cost too much at JLC. I know if you have it done in the US, it would cost $800 minimum because they have very high minimum order costs. But with JLC, I think they can work their magic.
Probably cost you about $8.
$8? That'd be awesome.
Do you send them the parts, or you just have to order them from their supply chain?
Yeah, they have different options. So you can send them parts. They can buy the parts for you, or you can choose parts that they already have, right? So they have these huge industrial grade pick and place machines, and they often have very common parts preloaded. So they probably have tens of thousands of 10K resistors or 4.7K resistors and other common caps. So if you choose those parts, it's extremely cheap because when they load your board in and then it pulls it straight from their machine. And sometimes they have to go back into storage and get a different reel. So they probably don't have the IMUs already loaded in their machine. So they have to go back and get those IMUs or maybe even buy them and then load them in. So they do charge a small fee each time they have to do something extra.
I'm assuming there's different grades of parts. I mean, not all parts are equal, as far as like tolerances and stuff like that. Maybe mechanical, dimensions, maybe a little off or something like that. Can you specify, a certain grade of part or something, or?
Yeah, good question. So when you're choosing the parts on their website, now I haven't done this, but I've watched the YouTube tutorials on it. They will have a menu almost based on your bill of materials, and you can choose from which JLC part that you would like to use for that part. So let's say I have a 10K pull down resistor that's specified in my BOM. There's going to be a column where I can choose which part that they have that I want to use for that. Alternatively, I can ask them to order the exact part, but that's going to have a fee.
So can you specify the manufacturer, who's going to make that part for you, or that you're going to buy that part from, or is it just whoever made the part?
Yeah. So here I've got a bunch of stack pull resistors, and that's a company. I have a couple of Yagios too. I'm not sure how it's pronounced, so I tried. I'm not married to those brands. If JLC has a cheaper one, I'll probably just use it because it's just a resistor.
Yeah.
And if it looks legit, I'll use it. If I want something in particular, like the microcontroller, the IMU, those have to be exact because all of my software is based around those parts.
Yeah.
So I'll have them get those. I do have some spare parts. It's mostly the passives. So I'm just going to keep those in my private collection until I have another project that requires them. But I'm getting tired of spending the $6 like each time that I want a microcontroller and an IMU. Those costs add up quick if I keep frying them on boards. So, and then shipping from DigiKey costs $6 or $7. Yeah, I was surprised. The total cost for parts, not including the circuit board on this thing, it's almost $60. Because I've got the photodiodes. They're not cheap. I've got the IR emitters. Those aren't too bad. But the IMU and the microcontroller each cost about $6. So it adds up.
Especially when you solder them on once and then you have to throw away the board. And
yeah, and this is the second time I've done this. I should probably stop trying the full board, but I'm getting greedy.
Well, that's a good update, Matthew.
Yep.
Thank you.
All right. Thanks, guys.
Next up, Kyle, you had something you wanted to show?
Yes, I have. Yeah. Not quite ready to share my screen, but I suppose I can record. Turn on my camera.
I don't know where it is.
Okay. So what I've been working on is pretty much the electronic sort of schematic behind my Robo Columbus robot. So not sure if I can't upload this. Okay, in the meantime, I'll try to upload the photo of my schematic. But what I was trying to do is power my bot with a hydro battery like this right here. And what I was trying to do is sort of step down the voltage. So the chassis that I'm going to be using for the competition, if I make it in time, is just a small like RC chassis like this. And I'm going to step down this 21 volt 5S battery to the same 7.4 volts 2S that the car uses for its motors, just so I don't fry the motors. But the problem I've been having was when I was trying to test different step down or buck converters to get to that safe 7.4 volts. This was my first attempt that I tried. It's called a DSN Mini 360. I'm not sure if you can see that right there. But it's a really tiny buck converter module. And I checked the positive and negative terminals and make sure that I put the battery on like the input side, not the output side. But what happened was when I wired some small jumper wires like these, and I tried some thicker wire with my second attempt, but the problem what happened was I hooked the wires to the input and I had no load on the other side. So it was just the input of this directly to the positive of the battery, the negative input to the negative of the battery. And what happened was this chip started smoking and the wires glowed bright red and like it just all like crumpled down. So it just melted out. I don't know what happened and I'm trying to figure out why. So I thought maybe it was because it was too high voltage for the chip. I checked the rating of this and it was around 20-ish volts, I believe. So I thought, hey, maybe that's like right at the edge. Maybe the voltage is just too much for this chip. So I tried the more popular LM2596 module right here. And so when I tried this one instead, the good news is it didn't burn to the ground. But the bad news is despite me using a thicker gauge wire and using well, I checked the voltage rating for this and it's at a higher 40 volts, I believe. So there was plenty of room. So the problem wasn't over voltage. But despite that, when I plugged in the battery, so the LED died. And I think I killed this buck converter as well. And I'm trying to figure out like what happened, like why this is happening, because it seems like a recurring issue. And it's confusing because I have no load whatsoever on the output side. And one of the things that I have noticed was whenever I tapped the positive or negative end, when I tapped one of the ends to close the circuit, there would be a small spark. It was a much louder, brighter spark on the smaller chip right here. And then for the higher voltage rating LM2596 buck converter, the spark was a lot less noticeable, and fortunately there was no smoking chip. The battery, the LED indicator, and the chip just died still. So I don't really understand like why the spark is happening, and even more confusing was the fact that there was no load on the chip itself. So like I was not connecting to any output load.
Yeah, well, there's a big capacitor on the input, and that would cause the spark, the current draw when you connect it.
Are you sure you're not putting reverse polarity on the board?
I am positive. I checked the polarity. I checked the polarity on the board, and I made sure to color code them correctly. So positive to positive, negative to negative, and I checked with my multimeter to double make sure. So it's not a polarity issue. Sorry, who mentioned something with a capacitor?
Yeah, I did, Mike.
Okay, so yeah, I did read a little bit about that. So capacitor, and then I'm not sure if inductance is the right word, but is inductance like when like the electricity like kind of like, or like when the current like pushes back, or I'm not sure if that would have anything to do with why it would fail.
Kyle, the best way to think of inductance is it's a resistance to change. So like if you have current flowing through an inductor and then you try to stop it, it's not going to stop instantaneously. It's going to have, that's what the inductance comes in. So it's kind of, think of it as a resistance to change. Now, where are you getting the parts? Because I've used both of those type of regulators before without too much major problem.
So they were from AliExpress. However, I did check the model number, which is at the bottom, and it was from a good quality store on AliExpress. So I don't think the problem is the board itself.
Well, the other thing that I might consider, I mean, I don't remember the output circuits of those particular boosts, but I know that some, if you have absolutely no load, that's not a good condition for them. So you might like take see, if you're running 5 volts, maybe pull 1 million, put a 5K resistor across the output. So that'd be 1 milliamp, and see if that gives you any better performance. Okay. I mean, just since you mentioned that thing, rule it out.
Wait, I'm sorry. Rule what out?
You mentioned in both cases these were no load. So they were the output was floating.
Yes.
And that might be not a good thing. So you go ahead and put a small load, like I said, something to pull 1 milliamp or something like that on the output.
Okay.
Just put a resistor there.
And the reason why I put no load was I was planning on using this as an alternative to like my microcontroller, and I didn't want. I wanted to test it to make sure that it's the right voltage.
But you have to check. You have to check the data sheet, because what Doug is saying is that some of these require a minimum load to be able to regulate the proper voltage. And if you don't give them the minimum load, then they're all over the board. They might over voltage and destroy themselves. So
another thing that I know the Mini 360 comes in a set voltage option, and I definitely recommend them because those little dinky variable resistors that they use on the Mini 360 are about as low quality as you can get. So just buy one that, and what I usually do is if I go into those, I actually take that off and put 2 new resistors in there. Well, I think you only need one resistor, and it sets it to whatever voltage you want it to be.
So when you say like a minimum load to prevent it from failing,
from the chip being in an unstable situation,
could like a small resistor, like a 220 ohm, or like maybe as small as
that's too much. You probably need that. What is your output? 3.3 or 5? What do you want?
I think it's 5. The output's going to be 5 volts.
Okay, so I'm saying pull 1 milliamp, so that'd be 5K.
Or
The-
1K.
The rule of thumb for a buck converter would be 10% of its rated current
Yeah.
Oh, minimum.
Minimum. Yeah.
minimum. Yeah,
You think so?
that's the benchmark for a buck supply is 10%.
Yeah.
Okay, that would be much smaller because I think those are 2 amps if I remember right.
So I don't fully follow when you say like the rule is like 10% of its rated current. Like, could you give an example?
Well, okay, so you got a 5-volt regulator at 2 amps, right? And since we're talking about a current load, we're talking about 10% at 2 amps, or would that be 20 mils, right? Or I guess no, it'd be 200 mils, right? That would be the recommended minimum load, because the oscillator in there and the inductor, I mean, just like Doug was talking about, inductors don't want to change. So if there's no load on them, right, it's very hard for them to regulate because there's very little current coming through there. So once you produce a little bit of current flow, now the inductor, which is the biggest part of that buck supply, can actually do its job, because now you're providing current for it to act on or to try to inhibit the change of. So that's why it's important to have some minimum load on that regulator. Some regulators, really good ones, the rating can be very, very low, 1 or 2%. But basically your standard off the shelf one, the rule of thumb is 10% load. That's what you really want to kind of run it at, because if you run it under that, it's really working much harder than it's intended to, because it doesn't have a load. It's trying to regulate into basically nothing. Now, I don't think that's going to make the supply wire overheat. So there may be something else going on there too, but putting some minimum load on it would definitely.
That's a good point. When you say this called the supply, bro. Okay, so that's the input side. Yeah, that makes sense. Okay, I'm sorry, Scott. I didn't mean to interrupt. I was trying to figure out why it was having glowing wires.
So from my understanding, the spark is because of the capacitor inside of the buck converters. Is that right?
Well, it's probably because
It's discharged, yeah.
Real fast somehow.
Well,
Yeah.
you don't have.
The
I would expect that you're not going to have that much capacitance on that buck supply, not on the input side of it. Because you're talking about
I see a
several hundred
schematic with
farad.
12 microfarads. I mean,
Yeah.
it's not much, right?
Right. Yeah, you're not gonna. You may see a little bit of a blip, but you don't have a lot of battery there. Let's say, put it that way, because
The only
you're
inductors-
instantaneously charging. When you apply power to the input side of that supply, you're instantaneously charging whatever filter cap is on the input side of that buck supply. And depending on what that value is, that's the inrush current that you're going to see. But I
Kyle,
think that value is going to be fairly low, would be my expectation.
Kyle, hold up
Yes.
that buck converter again.
So the mini one.
Yeah, so you don't have enough capacitance on there to create a spark.
Yeah, there's a capacitor just on the right hand side.
There's 12 microfarad on the input and 12 on the output, according to the schematic I'm about to paste.
Yeah, I think that's about right. And anyway, like I say, you can get that in a set voltage version. I highly recommend, if all you're doing is doing 5 and 3.3, just buy the one that's made to do that, because you hold that chip up again.
I would second that recommendation as well.
Yeah, Kyle, if you look at that chip, you see that little dinky, looks like a little metal ring on it. on your 360. Hold it up.
Yes. Let me see if I can't share this tab right here. Yep. Okay, is this? Yep. So something like, so this is the front side. Are you talking about this thing right here?
No, see this? This is a, especially in a robot, this is a problem just waiting to happen. Because once your robot starts bouncing around and everything, this thing is going to start popping around too. And so your connection, the wiper on it is going to lift occasionally. It'll be very small. It'll be very quick, but it's just a problem that you don't want to have. You can get these, if you look up, go up here, up to your Google thing and put 5 volts. No, just the same thing you had, put 5 volts. Now hit search. Let's see. You should be able to find some that don't have that. None of these. These are all the same. They're just saying they're adjustable.
Okay.
But if you look around on like Amazon, you can find them where they don't have, they're just made for 5 volts, or they're just made for 3 volts, 3.3 volts.
Okay.
And just buy those. This regulator is very cheap.
Okay.
And I mean, you can get like 10 of them for $5 or something like that.
But the big square is your inductor.
Yeah, the big square is the inductor. Well, I think it's actually a transformer. No, it's an inductor.
Yeah. And the round things on both ends are the capacitors.
Yep. No, the rectangular things that are on the ends.
Yeah.
Ones that stand up high.
The brown, the rectangle.
Yeah. There's one on each end.
Yeah. And that metal thing is the potentiometer to adjust. And
and that's what you're going to get rid of.
Right. Because he's saying that'll jump around and change voltage and stuff.
Well, you don't know what it's going to do. You know what I mean?
Yeah.
So by changing voltage, as in like over time, that potentiometer is going to like shift, and that's going to change the voltage and eventually ruin it.
Well, no, what it's going to do, it's going to be, if you were to look at it with an oscilloscope, that potentiometer is one of the 2 components that makes the feedback loop for the chip. Okay, so that's how they set the voltage. It's a ratio between that potentiometer and a fixed resistor that's on the board. So if that ever opens up, then your feedback loop gets distorted, or probably might even be broken. And so the output voltage is, until it hits back, and it's not going to like bounce off and stay off unless you just happen to have a bad one. But it's as you're bouncing your robot all over the place, there's a lot of jitter. I think Carl had an excellent example of what can happen. He had some 18650 batteries that he put in. They had the little spring thing on them, and he was actually seeing the battery disconnecting every once in a while because of the vibration in his robot. I remember him talking about that. Okay, so I found one here, but that's not the one I wanted. Let's see if I can find.
I just put a link in, 5 for $9 on Amazon.
Yeah, I put a link as well to a Canadian and American site.
Okay.
Oh, there you go.
Yeah, great.
So the thing about this is, while like some of these, so check these after the meeting. Like, of course, like with the time crunch, because it's the Robo Columbus thing is happening this Saturday. So I just want to use like the modules I have. So there's this one last resort option that I do have. Let me see if I can't search for it right here. But it's one of these modules right here. So it's supposed to be part of a bench power supply. And the reason why I chose this one was because it has a much higher current rating. For the ones that I did have, the max current was like between like what 1 and 3 amps, which if I was going to directly power the motors, that would not nearly be enough. So I was thinking on borrowing this bench power supply. I'm going to search for the exact model because I did have it saved somewhere. But I also wanted to, like, before I test it and before I accidentally destroy another buck converter, I just wanted to like figure out what went wrong with my previous ones so that I don't do the same thing with this one.
Yeah, I think, Kyle, the answer, since you're under such time pressure, okay, I probably used the LM one, the one that was a little bigger. And I would probably put, I believe that's a 2 amp regulator, if I remember right.
I have to look it up.
And,
yes.
And so, and Scott's saying 10% on it. I don't know if you have to go quite that high because you're going to have load on it when after you finish testing. But if you want to test it, put okay, I think they told you what resistor it would be. It's okay if it's 5 volts and you want to pull 200 milliamps, that's going to be pretty small.
25 ohm and 1 watt.
Yeah, I don't know if I want to go that. I don't think you need that. I think you could get away with
1K or something.
Yeah, something like that. Just, you're just testing the module, right? That's all you're doing.
Yes. And also, like, for this one here, the reason I was going for this LTC converter was because it has a continuous current limit of 7 amps and a peak current limit of 10 amps, which is I'm sorry?
That's a nice module, but you don't need that, I don't think. I mean, how much? What's your current budget on your robot?
By budget, do you mean like per like
what's your amperage? What are you running? Yeah, what are you running off of it?
So
you're not trying to run the motors off that.
Yes. Well, I'm not
I
sure.
I'd use a separate regulator for the motors and a separate one for the logic.
So I'm trying to figure out what kind of
It's a good idea.
regulator I should use.
Yeah, for the motors, you just let them go full battery.
This is the piece that doesn't.
Part of his problem is going to be he's doing micro mouse, man. You got when you're talking grand.
Not Kyle. He's
Wait,
not.
this is not Micro Mouse. This is for Robo Columbus.
Okay, never mind.
Yeah.
Never mind. I got confused. Sorry. I will shut up again. Okay.
Yeah, no worries. Let me pull up my schematic because I uploaded it just now. Right here.
Yeah, I would also use a lab supply instead of a battery to just test it.
It'll ramp up slower and that kind of stuff typically.
Yeah.
I could, yes. So this was pretty much, it's a very, like, it's not a professional schematic, but it's just kind of like to get my idea here. So I don't know why I said 12 volts, but this is supposed to be the 21 volt battery. So 21 volts right here. And my original plan was to go from here to the buck converter, which will step down the 21 volts down to a safe 7.4 volts. 7.4 because that's the same voltage that the motors originally went with. So I think it's a safe number.
Can you show us the motors, Kyle? Just real quick.
They're not exposed, but
okay. So this is a RC car.
Yeah, it's a pretty cheap RC car. The motors, they're not huge, but like I'm not sure if you can see like right there. I'm not
Okay,
sure if
let
that's
me ask
visible.
you this. What was the battery voltage that was supposed to go with that?
Yeah, I flipped the numbers around.
7.4.
It's 21. It's a 5S battery, so 5 in series, 21 volts.
Why are you using a 5S battery? Because your car is probably it's either a 2S or a 3S. And if I looked at your diagram, it looks like it's a 2S. It's a 7.4 volts.
hmm
The ones that are going into your dual ESC.
So the reason why I chose this was because I'm just making the most of like the resources I have, and this is like my idea was like these are really hot swappable, and I have a second battery of this, so I thought it'd be just like super easy just to like
Yeah, I'm going there too.
slide off, slide on,
Yeah.
real convenient.
And Harold's been using them for years. I do think I've got a good collection of those guys now because of other tools. So I'm going towards that myself. So
yeah.
Do you have a 7.4 volt battery?
There's the batteries that it came with right here. But my only concern is I don't know if it can draw. So yeah, I'm not sure if it has enough capacity to like hold off like for the entire run. How long is the run? Is it like 3 minutes?
Well, if you're only trying to get a 1 point and get a mug, 3 minutes is on an RC car is probably about right.
If I were trying for like saying try my best to go for maybe at least 2, like I mean, would these 2 small like lithium ion batteries be enough?
Yeah, those are 18650s. Yeah, those will, if I were doing this, and especially your timeline, I would use those batteries as your primary batteries. Okay. And just run them, one of your 7.4 to 5 volts. Because, if you look at your diagram where you have the BEC, you can see you say that 7.4 to 5, but you show it coming in from a 12. So that's but if it's 21, it's even worse. So
what I meant to do was to go from the buck, the 7.4 here, from the buck converter to this. Yeah, I made it quick, but yeah. So after the buck converter steps down to 7.4, then step this down to 5 to power the Pi. And I don't know, for this LiDAR, I have the module with me right here. I was trying to look online. I probably have it, what voltage it supports, but like if you undervolt this, like say it's 6 volts, but you only run 5 volts through it, like would that be bad, as in would you get inaccurate readings, or how would that work for these simple like LiDAR modules?
Just looking at that particular one, I could make some estimates. I would say, okay, is that the board from
it looks like it might be, James LaCroix.
Yeah, that's what it is.
Yeah.
Okay, on that one, that's got a feedback loop for the motor. So it's actually, if you use his code, it actually has a feedback for the motor to keep it. And the motor can be ran open loop on those things and does pretty good. But if closed loop is always better. But for this, you remember it's already Tuesday, and you got Wednesday and Thursday and Friday. I would cut this way back. I would try to get rid of the LiDAR. Don't worry about it.
Get rid of it. Yeah.
Not going to do you a whole lot of good.
Wait, why do you say that? I mean,
well, I mean, in theory, you could have some logic that went like this. If I go a certain distance and I don't see this has no GPS on it. So you're not using a GPS. So, and you have, but it says you have wheel encoders. So you're using wheel encoders. I mean, and if you have Teensy, you can, I don't know if you really need a Pi Z2W. I'd probably not have that. I'd probably run the IMU through I²C on the Teensy.
Why would I not need the Pi 02W?
Well, you got 3 days, dude. What you really want to do is cut this down to try to get 1 point. So that means you're going to aim it and let it roll, and hopefully it'll cut the circle. That's what you're trying to do.
How much software do you have already?
How much software?
Yeah.
Admittedly, not much.
Okay, yeah. You don't have time. You gotta cut this way. Your expectations.
Yeah, but guys, he's got GPT and vibe coding, right? They can crank this stuff out for him in a heartbeat if he can wire it up. But still, keeping it simple will help you a lot.
Yeah.
Yeah. I would use those 2 batteries on your remote car and the 7.2 to 5 volts. Get rid of the LiDAR and keep the rest. And that's a manageable project. Yeah.
Okay, so I'm gonna as quick as I can just make a super quick sketch of the updated version. So the reason why I picked the Pi Z2W was I didn't draw it, but I was going to have a camera mounted on it, and I have experience with OpenCV, computer vision stuff, so I could whip up something in not too much time. So the new schematic graph, instead of using the 21 volts step down to 7.4, I would use the direct batteries from the car.
Right.
Then I would feed that into the dual H bridge.
Yeah.
And then that'll power both. And then since this is 4-wheel drive, basically the front and wheels are have their own separate motors. I think it'll be fine if I wired both motors to a single since it's a dual H bridge, you can wire 2 motors, but since these top 2 they're going in the same direction, it's just extra force and extra power for the motors. But would it be fine if I wired both of those motors right here to the same part, the same one on the H bridge, and then use
you can put both of your left motors on one side and both of your right motors on the other.
So
there could be if you had a year for next year, then I would say, well, you might want to do them individually so you could have a little better match, but real rough, just put the left on one of them and the rights on the other.
So my reasoning is this: I put the both of these on one, and then for the second one, I use that second one for the driving, which is just a small motor that steers them the front ones left or right like this, and then something.
So you're only using 2 drive motors.
Yes. So my question is, if I hooked both of the drive motors to the same one, would that reduce the power? Would it divide the power across 2, or would it draw more from the battery to power both of them?
Draw more from the battery.
Double the power.
Yeah, you have the load. I mean, you double the load, I guess is the right way to say it. You have the impedance. So
Oh wait, impedance, that was the word. When I was trying to research this on my own, so there's inductance, which is the resistance to change, but when I was describing like the sort of like the bounce back force, like I think I was trying to describe impedance. So like how do you describe that in simple terms?
Okay, so impedance, all right, is actually it's when things are not moving in steady state. So you have capacitance, inductance, and resistance. All three of them, when all of their effects on the circuit is the impedance. Okay, so like if you're only using resistors, you only have a resistive load, which usually you never have just a resistive load, but then you could just use calculations resistance. But if you have an inductive load like a motor, and you have capacitors in there, then you have to talk in terms of impedance.
Okay.
Okay, so impedance is okay, so if you want to look at the three things, resistors are just like a reduction in a pipe, okay? Capacitor is the resistance to change in voltage. And an inductor is the resistance to change in current.
Wait, okay, so resistance, change in voltage, inductance, resistance and change to current?
The resistance to change in voltage is capacitance.
Okay.
Resistance to change in current is an inductor.
And then what about impedance?
Well, impedance is the combination of resistance, inductive, and capacitance all together. So but from here, from a low level, you probably just need to think of them in terms of load, how much current going to pull.
Yeah.
Okay.
So the reason why I was inquiring this was because that was one of the words that was being floated around when I was talking with Gemini, trying to figure out how to solve the problem of why these things are exploding. But like, is impedance one of the like factors that may like be causing like why the buck converters are blowing up?
Well, I think our best solution that we've given you so far is to put a load on it. Okay, now once you have all of this connected in your circuit, then that's a load. But if you're testing these on your bench, you need to have some sort of load attached to it. That's what we're really saying. Okay, so if you knew your buck converter was cool and everything was happy, and you put it in here and you were driving a teensy and a Pi Z and wheel encoders and an ultrasonic and IMU from it, you wouldn't have to, you don't have to put an additional load on it. But if you're just sitting on your bench trying to see if it's going to work, then you need to put some sort of load on it.
But if you're only putting a load on that's like 5 or 10 milliamps, that's not much of a load at 5 volts.
No, you're right.
It should be enough to help it regulate. But those things are switching regulators, which means they're very efficient, which means they shouldn't heat up at all.
Yeah.
So if you're pulling a big spark when you connect the wire, if it's letting the blue smoke out, that these things are powered by smoke, of course, because when the smoke comes out, they stop working. So that's how we know they're powered by smoke. So if you let the smoke out, then you might want to be a little more. It could be a bad part. Maybe there was an accident on how the probes were connected to the circuit card. Maybe it was sitting on something conductive. So, like if you were sitting on a metal table, maybe it shorted out the circuit card on you, and even though you hooked up the power right.
When you said the power supply leads got very, very hot, that's telling you that they're taking a lot of current. Okay.
Yeah.
You really shouldn't see that on the input.
Mhm.
So it's a bad part or it's wired wrong.
Right, exactly. Thank you, Carl.
Which stuff from
Use a
China?
lab supply.
Probably
Yeah.
suspect a bad part.
Yeah.
Yeah.
Yeah. So how many did you get, Kyle, when you got them?
5.
How many, or like when I purchased it, how many did I get?
It was a 360s little one.
Yeah, it was a 10-pack, so don't worry, I have plenty of spares.
Yeah. So what I'm trying to say is, I would, if you blew one up, I'd just say you try another one. Now, if you blow up 2 more, then I'd quit and say that you got some bad parts from AliExpress.
Yeah, I have a feeling that I was doing something wrong because I have used buck converters like those before in the past, and they work perfectly fine. So maybe it was the over voltage.
Yeah.
Yes. So
Yeah, the capacitor could short out if it's over voltaged. Yeah.
Yeah, because
Okay,
they have a
so-
certain rating. Did you actually test the output voltage of your battery pack?
output. I like
Your
testing,
voltmeter.
like using my multimeter.
Yeah.
Yes, I have. And it did read 20 point something volts.
Okay. Yeah. So I think what's the recommended input? Like 23?
Max.
Yeah, it's like 23 or something. So it was like right on the line.
Yeah.
Like that, like even if it was just right on the line, I just didn't understand why it would just like explode like that.
Yeah.
Right.
Yeah. Usually if your wires are getting hot, you've got like a dead short somewhere. That's drawing a lot of current off that battery.
Right. Well, just for curiosity, when you looked at the board after that happened, was there any scorching on the board?
That was a weird thing because I saw visible smoke and the one of the wires, like it was glowing like an orange hot, like a glowing orange. Yes. And
that is a lot of current.
That'll remove your fingerprint, by the way.
Yeah.
Were you using just one of those little DuPont connector jumpers?
I was. I think that was part of it because I do know that the thinner the wire, the higher the resistance, more resistance.
But here's another little tidbit: is those DuPont connectors you get from China. Not all of them are good. A lot of them use copper-coated aluminum wire, and they use a small gauge. So, and you'd be amazed at the voltage drop between one end of one of those things and the other if you're pulling any amount of current at all.
Significant current.
You're talking probably 0.4, 0.5 of a volt drop on that one of those things. Yeah,
So it's been pulling
the output. Yeah. So you
Shouldn't have been pulling current, though.
regulator. You have a 5-volt regulator, but at the actual circuit board you have 4.5 volts because your wire's really dinky. There's a resistance. Drop the voltage.
Yeah.
I bet if you look at those cards before you plug the next one in, it's not that many parts. So I would think you might want to just look closely at it and see if maybe there's solder blobs and solder bridges on the board itself before you give it power.
Another
Yeah,
good
and now, so the thing, like, you're thinking, like, if I soldered a short?
Now, I'm thinking it might have come to you with a short from the manufacturer.
I don't think they
Sometimes-
test you.
Yeah, sometimes when they build them, they can have manufacturing flaws, and it'll come with a short on the card itself.
Now, that's something I probably would have thought about, but the weird thing was that it was a consistent issue. Like, the same thing happened across, like, 2 different buck converters of different brands, different models, and I bought them from different stores, I'm pretty sure. So,
and you're
I'm
certain you
feeling-
didn't reverse your leads on your...
100%. I double checked.
So there's another thing you could do just to save your parts and your sanity is put your DMM in current mode. And the next time you apply power, use the leads from the current probe on your DMM to apply power, and just watch to see how much current that it's drawing. Because if you have only a couple milliamp load on the output, those things, I mean, what guys, 10, 20, 30 milliamps? If it's much more than that, there's something wrong.
Yeah. If you're reducing voltage, the input current will be always less. If you're using a buck converter, the input current will always be lower than the output current. All right. If you're using a boost converter, it's just the opposite. For every amp you pull out of it, you're probably taking an amp and a half from your supply. So,
but still, a lightly loaded converter is not going to draw much current on the input at all, right?
Right, exactly.
And if he's getting smoke and melted wires, he's pulling amps.
I wouldn't put my digital voltmeter in there because Carl, he's got I mean, he pulled more than 10 amps.
It's got a fuse.
I'm not sure I want to have that in my have that going through my meter.
It's just a fuse, yeah.
Unless it's got one of those meters that clamps over it and has a Hall effect sensor in it to accurately do DC current.
It's not a fancy meter. It's just some I think it's like a cheap $20 one, but
it'll have a fuse, I'm sure, and it'll be rated for 10 amps probably. You got to watch the current rating.
Yes. Yeah, make sure you put the leads in the 10 amp lead point, not in the normal 100 milliamp.
The Harbor Freight leads were notorious for melting at 10 amps. They weren't very good leads.
Yeah. It's a fuse.
So the leads themselves would melt.
Fuse.
They were made by the same manufacturer as the Chinese DuPont connectors.
This is where the trick I'll use is you get a current limiting bench supply and you set the current limit to some low value like 2-3 amps, and you set the voltage, and then when you use that instead of the battery, you can check that like in this case, the buck converter is working correctly, and you're not going to destroy anything.
Okay.
And then the bench supply would tell you what current's being drawn.
All right. So this is my real quick. This is my updated simple oversimplified schematic. So I changed it so it's now feeding off directly from the batteries or from the car. So I don't need to step it down for the motors, and then I'll feed it through this high current driver. This is supposed to say 40 amps. And then the first one will be the first part of the H bridge will be powering both of the drive motors. And then the second part of the H bridge will be powering the steering one. And then this down here will be the BEC that steps it from 7.4 to 5 volts, feeds it to the Pi, and then the Pi will be communicating with the camera, the IMU, the ultrasonic, which will be for detecting when it's right in front of the cone, and then the encoder for the wheels.
Okay. On this, Kyle, this is much cleaner. I would say this though, you don't want to use a Mini 360 there because I don't think it's going to have enough current to run the Pi and all of that other stuff.
Oh, for the 40 amp? Wait.
For your 7.4 to 5, you need something. You're probably going to need your big module because the Pi, I think, takes 2 amps by itself, doesn't it?
This is the 0-2W.
I think the 0 takes 2 amps, doesn't it?
That's like a max. Yeah.
Yeah, anything Pi takes a lot of current, but I forget what it is for the 2W.
Yeah. At least at peak, because when they boot up, sometimes they'll draw a lot.
Yeah.
Which means if your converter is not strong enough, it'll starve it and it won't boot.
Yeah.
Yeah. The Pi 0-2W is a very tiny module. It's not like the Pi 5s or anything like that.
I know, but it still takes current. Look up the current, the minimum power supply. Well, I guess we can do that.
The
What's
peak
the rating?
current I found was 500 to 580 milliamps for the 02W.
Yeah, it's about right. And not in idle once it's come up. Yeah.
Okay, so for this part, to power the camera, IMU, ultrasonic sensor, and encoder, I mean, those are pretty low power modules. You're not running any big motors or anything like that. So those combined with a Pi, the LM2596 should be more than enough to safely step down all of that. Like all of this should realistically be under 1 or 2 amps current, right?
So you should add it up just to check it.
Yeah. Let me do that real quick. There was one more question I had.
And then the other thing is sometimes those buck converters, I mean, they might be rated at a high current on the output, but that may only be for the case when they have a proper heat sink. So you need to make sure that if you're within the current budget, that you have it properly heat synced to dissipate the heat.
Wait, say it again. Which ones of these needed the heat sink? Was it the BEC or was it the Pi?
The BEC. So
your voltage regulator, your buck.
Yeah.
Yeah.
So what I put the heat sink would go on this.
Well, you can figure out if you need it or not, but you got to check the specs. So like, it'll be rated for how much. The electronics are rated for a certain amount, but then there'll probably be two numbers. There's one number for if you use the electronics just bare, and then there'll be a higher output current capacity if you put a proper heatsink on it. So that's where like it's good to get another piece of paper and just have a power budget so that you know how much current each one of these little boards is drawing and add them up and make sure you know how much power that your BEC can provide, and then check the data sheet to show that the BEC can provide that power with or without the heatsink. So.
Okay, I just looked up the recommended power supply for a Pi 02 is 2.5 amps. So I'm not saying you're using it all, but that's what they recommend that you drive it with.
I'm not running any fancy algorithms though. It's just a simple OpenCV, just like detects the color orange or like the shape of the cone or like something very simple. It's nothing that's going to throttle the zero to my knowledge.
No, but I'm saying your power supply, the power budget, that I know you're probably not going to be using the 2.5 amp, but that's what they say you should supply.
Okay.
So
that sounds like a copy paste error to me, but that's just me.
No, I think it's a real number because the current with these processors, the current can be very dynamically changing very quickly. So even if the average current that you might measure with your DMM is 500 milliamps, the instantaneous peak current might hit 2.5 amps whenever you run that one part of your CV algorithm. But it'll only do 2.5 amps for like milliseconds or microseconds. But the trouble is, if it needs that much current for 10 milliseconds, but your BEC cannot provide it, then it's gonna crash.
Yeah, so I'm just saying,
yeah.
So you might want to use your big one for that BEC. You've got one.
By big one, you mean this huge power supply one?
Yeah, yes.
Yeah. So this is the LM2596, and this is the big power supply one.
The top one would be the safe way to go. You might get away with the one that you were holding up below.
Yeah, I used the small one that he had to power a Pi 4, and it worked fine on my robot.
Okay.
And that was the LM25.
Mike?
Yeah.
With a camera?
No, I used a separate regulator for all the sensors and stuff. So I put two buck inverters, one for the Pi and one for the sensors.
Okay, Camera's going to be on the Pi because you can't use it separately.
Right.
Wait, so you're saying that you had a separate converter for the Pi and for the sensors?
Right. Yeah. Just to share the load so they don't interact with each other. Because they all power up with a high power load or high current load, and
So I could use
2 of them. Yeah.
Yes, so like 2 like in like parallel with each other but separate. So one for the Pi, one for the sensors.
Right.
Okay.
Both powered from the batteries, but you wouldn't want to tie the outputs together. That would be
Just
dangerous.
make sure the grounds are tied.
Yeah.
Mm-hmm.
Yeah.
Is there actually I was wondering, like, because I've always been recommended to always share like a common ground. Are there ever cases like in like robotics where you would not want to share a common ground?
No.
Okay.
Probably not.
Nope.
Yeah, everything has to have
You
that
don't
common
want
reference
common
point.
ground? I don't know about that.
I mean, on the stuff we do, and I think what you're doing, you're not going to have any floating outputs, right? You're not trying to you're not trying to isolate you're not trying to isolate from one side of the robot from the other side of the robot.
I don't think so. No, I'm not sure why it would.
Yeah.
No. To keep it simple, you're not.
Yeah. Unfortunately, I think the LiDAR that you showed came out of a Nito, and I think they were really intended for indoor use. I don't think it's powerful enough like the one that Mike Williamson or Doug have that costs a whole lot more.
Do you know
several
the range?
$100 more for outdoor use.
Yeah, it probably wouldn't work well, and it's not very useful anyway. I found out.
And what range is the like several $100 one versus the one that I have?
40 meters.
40.
Yeah. And it's actually
20,
probably
40. Yeah.
Yeah. And I don't know if you could get one for $400. We're talking about like an RP LiDAR, which is it the S3? S3, I think.
Yeah.
Is like $500, maybe $600. They're really gone up.
Now I was wondering, like, would it be overkill to like purchase like, I don't know, on AliExpress, like one of those Unitree? I've heard that they have those Unitree, like the 40 LiDARs on sale. I'm not sure if something like that would be overkill. Like, has anyone used something like that before?
I'm not certain which ones you're talking about.
So for Unitree Robotics, they sell the LiDAR module that I use on some of the dogs. It's like this, where it's pretty much an omnidirectional LiDAR sensor that you can integrate. I'm not sure.
That's a 3D LiDAR, I believe.
Yeah, it looks it.
Yeah.
Huh.
Let's see if I can click on it.
That's a lot of data to process.
Yeah. Yike.
I don't think we've had anybody use something like that.
Not to my
You're
knowledge. Yeah.
you're a pioneer if you're going to use one of those on a robot.
But you need a Pi 5. Yeah.
Probably. Yeah.
And a lot more than those 2 little batteries that you showed us.
Has anyone ever strapped, like, if they needed more processing power, like strap like a small cheap laptop for like a sort of budget alternative to a Pi?
I think way back in the day, the early days of the DPRG, I think, they used to use laptops as the main processor for the robots. But I remember Dave Anderson talking about that, but I don't know how common that was.
So I've heard of people replacing Pi 5s with it, like an Intel NUC, an N100. It's a little better processing power. It's an Intel chip, so software tends to go a little better.
Yeah.
Okay. I guess like that summarizes most of the like concerns. So I don't think I'm fully like kind of like perfectly clear on like, so to my knowledge, just like make sure that you have a load to ensure that the buck converters don't blow up. Is there anything else that like, is that the main reason why both of them like failed the way they did?
Could be like what Carl said, that, you know, they may have been shorted to start with. You can actually take your voltmeter and stick it across the input and see if it's a, you know, a 0 ohm short. I have the same ones that I think that you have, and tried it, and they all look open on the 200 ohm scale. So
that's
if yours show a short, then I'd say you definitely have some bad converters.
Yeah, I bought a batch of them, and 2 of them didn't work. So, yeah.
Oh, seriously? Yeah.
Regard to the question about robots and computers and small computers onto it, you might talk to Eric, because he puts a small computer
Oh,
on
yeah.
his Lego thing.
Yep.
So that's one right offhand I can think of, and there's been others.
I'd be tempted to use an old phone and just use a
We ran
USB
a phone. Yeah, in fact, we had one person a couple years back that had a phone that was connected to, and he used the phone as the sensors for the GPS and stuff.
Yeah.
And even for the camera on the phone.
Yeah. You can you can hack the phone and you just write Linux on it. So yeah.
Ray, weren't you doing that with a robot, using a phone as a processor?
Yeah, I was using MIT App Inventor, and you could access the compass and the GPS on the phone, and it was very simple to do.
But I was thinking you could use a phone as the main processor, and connect to the peripherals through the USB port.
Yeah, you might be able to. It didn't
could
seem
be
like
done.
App Inventor had support for that, but
Yeah, you get a lot of power, a lot of processing power,
mm-hmm.
and low power budget, but good CPU power.
Yeah, especially have like maybe something with an octa-core in it or something.
That'd be a great project.
Yeah, I don't know.
But not for this weekend. Yeah.
No, definitely not for this weekend. No.
So Kyle, one thing you might do, if you find that you've got one at least or more than one of those little converters that run, well, if you choose to use those, you could use like if you find out that when you hook too much stuff up, they get warm to the touch, you could just put one converter on each of the loads. Have a common ground, but you could have like one for your camera, one for the Pi, one for the I forget the ultrasonics.
Yeah, I do think that is the plan I'm going to use. Just have 2 converters and then split them for one for sensors, one for the Pi. And then one thing that I have noticed is checking the resistance with my multimeter. The input was like 10 mega ohms for this good module. So if it's like that much resistance, why would it explode like that?
So
I would say probably the one that blew up didn't have that high of a resistance, probably. Or maybe it did for a very short period of time and then it went really low.
But having a resistor in series, like you have the battery, then you have the buck converter, and then you have a resistor, like would that be enough to like limit the current so that doesn't happen? Similar to how like a simple LED circuit.
It could prevent it from working too, because
yeah,
it had to be just a couple ohms, but yeah,
it'll fight the buck converter, because it's going to want to drop some current. The more current the load takes, it'll drop your voltage across the resistor,
and it'll heat up.
And it'll heat up.
Yep.
So
Okay.
the real trick is to get the switching supply, the buck converter working properly.
Yeah, tie a temporary load into it and try it again with your battery.
And use a lab supply if you have it. Yeah.
If there was an instance where I wanted to test a converter, like for the ones with a potentiometer, sometimes I would not want to hook it up to anything for safety because I don't know. Well, I guess I could use a multimeter, but I want to like set the voltage using the potentiometer before I plug it in. So, but how would I do that if I'm supposed to plug in a load beforehand?
Well, you just attach the load to the output and turn it on and adjust it down to whatever voltage you need it to be.
Okay, good. Get a LED with a resistor as the load, or you have an old incandescent flashlight bulb or something. You know.
Do you have a breadboard?
I do have a few spare breadboards, but the problem, or like my concern is, say, like, for example, the simple LED circuit. You have your resistor LED. How would I, how do I say this? I'm trying to get, if I plug in the load before I change the voltage, I buck it down to a safe amount, that it might blow the LED from over voltage. So, like,
yeah.
Do you understand like my dilemma? Like what?
The output voltage 17 volts. Yeah. So you need to figure out which way gets the voltage down as low as possible, and crank it up, or go with something simple like a flashlight bulb or a resistor, or an LED with a big resistor.
Quarter watt.
Yeah.
Does your car? Do you have a vehicle? Does it have a 12-volt tail light?
It might. I'm not certain. But why do you ask?
Steal the bulb out of your tail light and hook it up as a load. It'll take a wide variety of voltages, well over 12 volts.
And plenty of amps.
And plenty of amps. And
more
then
amps than you
power
got.
it up, and you can adjust it till you get your 5-volt output, 5.1 volts.
All right. Well,
yeah, usually on potentiometers, they're, of course, I say this, and it'll probably be just the opposite, but usually increasing or going clockwise increases the output voltage. But so you could turn it all the way counterclockwise, which would reduce the voltage all the way down, hopefully close to zero, and then turn it up. So that's another way to
put it in the middle and assume you're going to get half the voltage that you're putting in.
Could be, yeah.
So if you're putting 21 volts in, you get 10 volts out.
Yeah.
Well, the output looks like it's 1 to 17, so that'd be like 9 volts if it's in the middle.
Yeah.
Oh.
But looking at this thing, I mean, the quick read that I did showed that they might not regulate as well. Like they might have tens of millivolts of ripple instead of much lower
noise. Yeah.
But the ones that I read indicate that this chip should be able, with this circuit, it should be able to run without a load and not explode. So
I've done that plenty of times. I'll hook it up to a lab supply, have no load on it, and just have my multimeter on the output and adjust the voltage, and then stick it in circuit, hopefully not touching the potentiometer.
It had a capacitor as a load essentially on the output.
Yeah, it's got a small one.
It's got a small capacitor, which should act as a load, not a big one, but
yeah.
It's not a DC load, but it should hold the voltage, right? So
yeah.
Mike's got a 400 watt resistor in his hand.
No, it's only a 10 watt. Yeah.
10 watt, yeah.
But that's the other thing, right? Because if you
that's what I use for my loads when I'm testing.
Yeah. Hello, Hydro. I'm turning on my robot.
But that's 7.5 ohms, right? So
the
trouble is if your resistance is too small, then there's no way that little Yeah,
Little buck
360
converter could-
module is going to be able to
It's
support
less
it.
than 1 amp. So yeah, at 5 volts.
for a short while it will, you know.
Yeah.
Just a little bit.
Very short. So you lose the fingerprints
Yeah, yeah.
Yeah.
Or the blue smoke comes out.
or the blue smoke.
Yeah.
All right. Well, yeah. Thanks for the help, everyone. I think I'll hop off real quick just so I can continue the project because time crunch. But yeah.
Yeah.
Good luck. Yeah.
I hope we managed to help you out a little bit, Kyle.
Certainly.
Well, guys, it's getting late.
Yeah, but I like my little resistor. It's great for loads. Yeah.
It's handy.
Yeah,
They
I've got a bunch of those too. Talking about something to lose your fingerprints on, that'll do it.
That'll do it.
Yow!
I've seen those glow. The one I got a kick out of is when he said a big wire, like a number 18. Well, I'm an electrician. A big wire is not a number 18.
A big wire is a number 8.
No, a big wire is a 1,000 MCM.
MCM.
It's the size of a silver dollar.
Okay, that's a big wire.
Yeah. So when you say big wires, well, that's what I think of.
Yeah.
Number 18, that's instrumentation.
Pretty much, yeah.
Yeah, but I replaced my 20 gauge wires with 18 gauge wires on my power, which they're good for 3 amps. Yeah.
Exactly. So, 16 gauge wire is good for 10 amps.
Yeah.
And that's about it. So.
Yeah, I like the Harbor Freight. There was several videos of those. You know, you could actually use those probes to measure current with, and the guy showed measuring 10 amps of current. The wires were starting to melt. Basically, they couldn't handle 10 amps. So.
And the last thing you want to do is grab a wire that's melting. I've done that. It's not pleasant.
It is not. When the insulation melts, it disintegrates in your fingers and leaves that hot little thin wire touching your skin.
Right.
It's like
I can see someone else has done this too. That's
yeah.
It's like one of those instruments or tools to cut styrofoam with a hot wire.
Nichrome wire. That's exactly what it's like.
Except it's your finger.
And nichrome wire doesn't glow red like the small wires.
So, Carl, how you getting along? Are you getting along mobile?
Are we done with the meeting? And I'll just turn off the recording first.
Sure.
Mm-hmm.
Make.
Yeah, look at this. I'm hobbling, but I'm getting around.